Hi, my name's Kenan. I'm a rising junior at Trinity School, and my main project here at Blue Stamp is the vertical axis wind turbine. And some things I learned here in general were a lot about how circuits works and then purchase circuits, such as transistors and amplifier circuits and capacitors. And the way all this works is that it's a wind turbine, and whenever wind comes in and spins this around, it helps like these LEDs light up. And the way it works is that as wind comes in, the wind gets caught in these sails here. And just turn this on. And you can see as the wind comes in, it spins these aluminum sails around. And then as this spins, they're connected to this metal aluminum rod in the middle, which acts as the main shaft. As that spins, turn these steers down here. This one's connected to the motor, as you can see right around here, which then sends the currents down these wires into the amplifier circuit. And since it's a bipolar stepper motor, that means that it can spin either direction. So right now it's spinning this way, but just in case for whatever reason, it is capable of spinning this direction. So because of that, the circuit has to adapt to that motor. So that means no matter which way the current comes down, it is still directed all down the right path with the help of diodes to the LEDs. And although the original design only called for one LED, I was able to put 5 of them in here, so to have divided load. And one of the problems I faced was one of my plan's modifications, and that was to make this whole turbine into a phone charger, charge any device that's USB compatible. And one of my problems at first was finding the right voltage, because since the way this works is that as you add more onto the circuit, it makes more resistance. And when there's more resistance, that makes it harder for the motor to spin, and therefore harder for the whole turbine to spin. So the turbine sails up here spin slower, so there's less voltage overall. And because of that, I was having some problems. This didn't connect up to 10 volts, but for example, when I put LEDs in there, I needed about 2 volts. So since I wasn't sure how it would react to the phone, I decided at first to put a voltage regulator in there to keep it at 5 volts. And in case it went too far below, I added my original starter project, the Mini Boost, to help boost in case I needed to. So although the voltage was fixed, I found the current gave me some problems, because I needed at least half an amp or 500 milliamps to charge a phone, but I only was getting about 50 milliamps. So at first I tried a transistor and an amplifier circuit, but I had some problems there. It wasn't really working as well as I was hoping it would. So I decided at the end, although it might still be possible to charge a phone with this turbine, that's something I'm hoping I'm working on later on, or if I have any time later on, if I had more time. Right now I figured that having these LEDs would work out. And it was through all this testing with the phones, I figured I realized I could add more than one LED onto the circuit. And also another problem I had was that sometimes, when I first built this, the turbine wasn't going as fast as I would have hoped. So first what I did was to reduce the weight of the turbine. I cut off some excess of the main shaft, and I was able to reduce 2 shaft holders, which are holding these into place with glue. And then I also cut out new aluminum sails to make them deeper, so they're able to catch more wind. And because of that, now I can turn on this fan, and it all lights up much more easily.